Hey guys, today we'll learn about double angles. They're essentially variations of the compound angle formulae that we can use to simplify trigonometric equations. And without further ado, let's get straight into deriving these formulae. Sine 2x. If we declare x as an angle of sine, 2x will be the double angle of sine, and we can hence write sine 2x as sine x plus x. If we take a look at the compound angle expansion of sine x plus y, where x and y are both angles, we can see that it equals to sine x cosine of y plus sine y cosine of x. When we apply the same principle to sine x plus x, we get sine x cosine of x plus cosine of x sine of x. We collect our like terms, and therefore sine 2x equals 2 sine of x cosine of x. Similarly, if we write cosine of 2x as cosine x plus x and expand using the compound angle expansion of cosine x plus y, which equals to cosine of x cosine of y minus sine x sine y, we can see that cosine of x plus x equals to cosine of x multiplied by cosine of x minus sine of x multiplied by sine of x. We collect our like terms, and therefore cosine of 2x equals to cosine square of x minus sine square of x. Now we know cosine 2x equals cosine square of x minus sine square of x. Let's take a look at the Pythagorean identity, sine square of x plus cosine square of x equals to 1, and see if we can discover something new. In this case, we can make sine square of x the subject, and it equals to 1 minus cosine square of x. If we substitute this into the cosine 2x expansion, we get cosine square of x minus 1 minus cosine square of x. Therefore, cosine 2x also equal to 2 cosine square of x minus 1. In the same way, we can also make cosine square of x the subject of the Pythagorean identity, which equals to 1 minus sine square of x. Substituting that into cosine square of x minus sine square of x will give us 1 minus sine square of x minus sine square of x. Hence, cosine of 2x also equals to 1 minus 2 sine square of x. Now we know all three of the double angle formulae for cosine. Let's take a look at tan. If we take a trip back down memory lane, we will remember that tan x plus y equals to tan x plus tan y divided by 1 minus tan x multiplied by tan y. Applying this to tan x plus x, we will arrive at tan x plus tan x divided by 1 minus tan x multiplied by tan x, which equals to 2 tan of x divided by 1 minus tan square of x. Now let's take a look at an example to further our understanding. Example 1a. Simplify sine 2x divided by 1 plus cosine of 2x. Now we should immediately be able to recognize that sine 2x equals to 2 sine of x cosine of x, and that cosine of 2x equals to cosine square of x minus sine square of x. Additionally, we can replace the 1 with sine square of x plus cosine square of x using the Pythagorean identity. If we collect our like terms, the denominator equals to 2 cosine square of x. We can cancel out 2 cos of x on the numerator and the denominator, leaving us with sine of x divided by cos of x, which we know is tan of x. In B, we're asked to find the exact value of tan 15. In this question, we're given an input of a tangent function, and this is almost identical to the result we got from part 1, tan of x. Since we know tan of x equals sine of 2x divided by 1 plus cosine of 2x, we can substitute 15 into both sides. Now we see that tan of 15 equals sine 2 times of 15 divided by 1 plus cosine of 2 times 15, which can be rewritten as sine of 30 divided by 1 plus cosine of 30, since 15 multiplied by 2 is 30. Let's recall the exact value of sine 30 and cosine of 30, which are 1 over 2 and root 3 over 2 respectively. Substituting the exact values back into the equation will return us with 1 over 2 divided by 1 plus root 3 on 2. If we multiply the denominator by 2, we'll get 2 plus root 3 all over 2. And since we know a over b divided by c over d equals to a over b multiplied by d over c, we can cancel 2 from the numerator and the denominator, leaving us with 1 over 2 plus root 3. In order to rationalize, we multiply the denominator and numerator by its conjugate, 2 minus root 3, and this gives us 2 minus root 3 over 1. Thus, the exact value of tan 15 is 2 minus root 3. In summary, we use the compound angle formulae shown on the screen right now to derive the 5 double angle formulas used for the 3 trigonometric ratios, sine, cosine, and tangent. Through this process, we discovered that sine 2x equals 2 sine of x cosine of x, cosine of 2x equals cosine square of x minus sine square of x, 2 cosine square of x minus 1, and 1 minus 2 sine square of x. And lastly, that tan of 2x equals 2 tan of x divided by 1 minus tan square of x. Thank you for watching.